Yes, good morning, colleagues. Maybe we can start, we can get settled. I know the last day is usually not easy because people are tired. Others probably went out partying, but thanks to those that managed to make their way here. I know others have even flown back to, to different places. So welcome everyone. Before I introduce my first keynote, thank you. So let me take this opportunity to welcome you and our first keynote speaker today is Dr. Felipe. He's from Intel. If you can come through, Dr. Felipe. Dr. Felipe is the CTO for Intel, EMEA, which is the Europe, Middle East, and Africa region. He's been with Intel for over 30 years, where he has held multiple positions, both in the technical support as well as in the sales side of things. He has managed several teams in technical pre-sales as well as supporting roles. Most recently, he was the director for HPC, which is the higher performance computing at Intel EMEA. So this is the kind of space that he's very familiar with. He holds a PhD in computer science as well as mathematics. He also has 2 patents in Japan on automated parallelization techniques. So ladies and gentlemen, let's welcome our first keynote speaker. And the topic that he's going to take us through is a very topical issue. That is the issue of AI. I remember even from the very first day, with our first keynote, Nevin did mention, whether it's the discomfort or the comfort with AI. So this is really a presentation that is going to give us that comfort in terms of the practical applications of AI, in terms of, in some of the aspects that, we have experienced, including at the Olympics in 2024. So over to you, Doctor. Thank you.
Thank you, Moore. First, let me tell you that it is really an honor to be here. Intel has been a partner of this conference for years. Unfortunately, this is only my second time here, but it's always with a great pleasure that I'm coming here. In some cases, Intel tends to talk a lot about technology. Today, I'm going to talk a little bit about technology, but before I talk about the technology that Intel makes, I'll talk about what the Intel technology and Intel make possible. And I will talk about the Paris 24 Olympics and what Intel did for AI there. But I know that there's another topic that people are wondering about, and it is what is happening at Intel at the moment. You probably heard that our CEO, Pat Gelsinger, retired on Saturday, or Sunday, sorry, and that now we have 2 co-CEOs, Dave Zinsner, the CFO, and Michelle Johnson Holthaus. Michelle has been at Intel for a long time. She has been in so many different roles, including the role of Chief Commercial Officer for some years. She has been running the client computing business very successfully with the launch of Intel Core Ultra earlier this year, Intel Core Ultra 2nd generation in September. She has been promoted to CEO of the Intel Products Group, which is great, and she has a passion for execution, which is perfect because Pat, our ex-CEO, has put Intel back on the trajectory for great execution. He committed 5 nodes in 4 years. We have delivered on the first 4 nodes, Intel 10, Intel 7, Intel 3, and Intel 20A. And we are already producing samples for the Intel 18A, which is 1.8 nanometers. They are working very well, these samples. Typically, they are Clearwater Forest, the next generation of Xeon E-core processors. And they will come in the second half of 2025. So back on the execution track that Intel used to be on. So I'm very sure that we will be successful at Intel under the direction of Dave and Michelle. Michelle said, no change to the strategy. we execute on the technology manufacturing leadership route, and we deliver on the products. So no change. That's what they will be doing at the moment. In parallel, the chairman of the board, Frank Yeary, is also looking for a CEO. So if you have a CV and you want to apply, please don't hesitate. With that, let me get into what I'm going to talk about today. So I will have several use cases for what AI did for the Paris 2024 Olympic and Paralympic Games and how Intel contributed to that. Here it will be really at what Intel made possible. I'll have a couple of slides on the AI landscape, what it is evolving towards, what Intel brings for AI from edge to a client, to data center, to the cloud. I'll have another use case which has nothing to do with the Olympics. It will be about healthcare. And then I hope that at that time, we'll get to the conclusion that, hey, the future is bright with Intel providing AI building blocks and solutions. So Paris 2024. Yes, I'm French. Yes, I'm proud that it was in Paris. Yet, I'm Intel, so I'm going to tell you about the great things that Intel did. Paris 2024 Olympic and Paralympic Games, and I insist on Paralympic because there are a lot of things that we did that was less seen in media. Paris 2024 was a big, big thing. It was a great success, and the videos that I'm going to show you, we took the risk of recording them prior to the Olympic and Paralympic Games, telling what we would be doing. Everything worked, and that was a challenge. So after the facts, we can be very happy about what we did. The Olympic Games, and I will call them as short because I mean Olympic and Paralympic, so it's OPO, is a huge event. There are about 3 billion viewers, about 15 million in Paris, with a little bit more than 10,000 athletes. And the big thing is that it's all in parallel. And the other thing is that there is one entity which is responsible for gathering all of the video streams from the cameras. It's the OBS, Olympic Broadcast Services. And then they dispatch to all of the media right holders, all of the country television and media companies that want to share with their users. And it is in many places. In Paris, several places. In France, several places, including overseas in Tahiti. So that's really, really, really a big, big thing to put together. What did Intel do on AI? First, Intel was the only worldwide official sponsor for AI for the Olympic Games in Paris. I have a list here, and I could spend probably the next 2 hours telling you about each of them in detail, because each of them is brilliant. You could consider that, okay, Intel did a proof of concept of some stuff at the Olympic Games in Paris. No, not at all. It is a real deployment of each solution in real life, at scale, in real time. So completely something that is not a POC, not a proof of concept. So digital twinning, when you have to prepare several years in advance all of the venues, some of them you have to refurbish, some of them you have to build. And then you have the media right holders and the OBS, the Olympic Broadcast Services, who say, hey, what will the lighting be like in the swimming pool area? Do you have the country teams that say, where will our athletes warm up? Where will they practice? What will be the path that they will take to get in the arena? All that kind of stuff. So you have to tell them, build it, prove them that it is built. They will come, they will visit, they will say, okay, lighting is not good, we need to change this. Wow, what a waste of money, time, and CO2 impact on the Earth for having so many people traveling. So what we did was we prepared digital twin versions of each of the venue, those to be built, those existing, those to be refurbished, and we shared. And then everything was perfect. We saved time. We were early in the game. 2 years before that, the event, the venues were available in terms of digital twins, and you will see some videos about that, and everything worked well. The OBS people knew exactly where they would put the cameras, how it would work, etc. AI-assisted highlight. Once you have the cameras, you have, as I showed earlier, several tens of venues. You have several tens of cameras per venue. All of the sports are run in parallel. You have so many flows of data going into the OBS center, the IBC, the International Broadcast Center. And then the media right holders, they want to please the people who pay the subscription for their services. What they want is that you are from South Africa, you are not in Paris, you want to watch the video replay of these athletes that you personally like, and then you subscribe to it, and you would have AI-assisted highlights, meaning that for you, there would be a version that would be cut of this athlete doing something specific. How do they find out? Let's say that someone scores in a game. There's a huge, loud noise in the arena. The AI catches it, knows that something happened, so they check. All AI done. They highlight the player that did it. If it's your player, then you will have this highlight sent to you, available on your media. Of course, not on TV, but if you are online. 8K broadcast, that was a challenge. That was the first time that we would do 8K on some cameras, on some venues. Each camera, in that case, generates about 40 gigabits per second. You have to find a way of compressing it without losing quality. And AI plus our compression techniques based on our accelerated solutions for compression and for AI brought it down to about 40 to 80 megabits per second, so divided by 1,000. That's perfect. That's exactly what we need. So all of this worked. The athlete AI-powered chatbot. And some of this you will see in the videos. So that's why I'm explaining to you, because you will be able to relate to it. Big countries who have a lot of money, they have much staff available to take care of their athletes. Even in those countries with a lot of money, there are some sports that have less money. Athletes are on their own. And I'm not talking about countries where money is rare and athletes have to be on their own. They have to practice, they have to prepare, but they also have to do all of the logistics. Where do I have lunch? Am I allowed to talk to the press? Am I allowed to bring some family members with me? And up to where in the Olympic stadium or in the Olympic area where people live and stay. What they told us in 2018 and 2020 was, or 21 because 20 Olympic Games were run in 2021. They told us we had so much trouble finding answers to our questions that it did not allow us to do what we were supposed to be doing, which was compete with a clean mind. So what we did was we took all of the data that the IOC had about all of the logistics questions, put it in a RAG engine, and created an environment for just the athletes to access this information through normal questions, interacting through their phone or laptop or whatever. And they told us, brilliant, I could have access immediately to the information clean, and I could forget about all of the logistical aspects. I could focus on the Olympic Games. Visually impaired people, we help them through a tool, again, through digital twinning, and then on their phone with their camera, they could navigate the areas where they were living and staying. With something that is marvelous, which is, hey, if this room had been digital twinned, and if someone is bringing a chair in the middle of the way, then a visually impaired person, even if they are told, you go straight another 10 meters, 5 meters, 2 meters, 1 meter, you turn left, if there is a chair, they will bump in it. So the camera system of the smartphone was capable of detecting that there was something changed, and they would tell the handicapped person, hey, there is a chair in front of you, slightly go to the right and come back to your original route, etc., etc., etc. I'll talk about just one more, identifying future talents. This is very, very interesting. I played with it. Okay, I'm not that fit, as you can see, but it can tell you what you are good at. You have to jump as high and as long in the air as you can. You have to run over 15 meters. You have to show how much you can catch stuff on a screen, something like that. And it tells you what you do. That was just for fun and to show what AI can do. But actually, if you don't know already, the Youth Olympic will be in Senegal in 2026. Intel went to Senegal and toured a lot of villages and tested some teenagers on their ability towards some sports with AI, but a lot more deep in terms of checking the features of such a sport in one athlete. I think that we tested really, not for fun, about 1,600 teenagers. 40 were, I would say, national level class or even worldwide level. With practice, they could achieve that. And one was already at an Olympic level already. These teenagers have now a chance of being supported, being trained, being taught how to do things. Without this option of AI check, they would have never been found. And that's very important. Can you get the sound up?
Platforms everywhere. Expanding 5G technology platform networks. Power your next-gen devices with advanced compute power and delivering 360 fan and athlete experiences on a scale that's never been done. Organizers are using a 3D digital twin platform to plan more efficiently, using Intel new levels of connectivity and data-forward experiences. End-to-end, Intel processor-powered software-defined workflows are helping Olympic broadcasting services simplify live worldwide broadcasts, enhanced by private 5G connectivity and hard-to-reach venues, while enabling rights holders to use AI for capturing and distributing more can't-miss moments. Volumetric video platforms help bring athletes closer to their fans, and AI tools help make it easier to operate facilities and improve accessibility for everyone. These fast, flexible, easy-to-deploy solutions are built with Intel processors, delivering incredible experiences for global audiences, and helping organizers with the potential to contribute to their revenue and sustainability goals. Intel is bringing AI platforms everywhere, expanding 5G technology platforms, delivering 360 experiences, and empowering stakeholders to operate at large scale with efficiency. Reimagining the future of the Olympic Games starts with Intel.
So you've seen here many things that I talked about: digital twinning of the venues, visually impaired, training for athletes. So all this worked. We said that we would do it, and we deployed it. Let's look at how we help athletes. I would summarize this with the following. It's not about practicing harder, it's about practicing smarter. And Intel AI-based solutions that we co-developed with ISVs and with the IOC, the International Olympic Committee, really were very, very helpful for that. Let's have a quick look at the IBC, the broadcasting solution that I talked about earlier. Remember that everything is flowing into a central area with many, many, many servers to get the network data, to process them, and then to distribute them and rebroadcast them.
My name is Marcela. I'm the head of broadcast technology for Intel's Olympic and Paralympic Games program office. Right now we are at the National Broadcast Center, IBC. This is a building where OBS, Olympic Broadcasting Services, manages all the content captured at the Olympics and distributes media rights holders around the world. A lot of the work that we're doing with OBS runs on Intel Xeon scalable processors, and they said that it's been critical to have Intel support to accomplish its goals. What Intel has done
the IBC was able to produce about 300,000 hours of program based on all what they got, but also creating additional highlights, summaries, gathering of data, mixing them, focusing on one country, one player, one sport, etc. So that was something brilliant. And remember one thing, we brought with the IOC the compute to where the data was created rather than we brought the data to where it had to be computed. That's the concept of edge. Because what we see now is that about 75% by end of next year of data will be created outside of the cloud, where at the edge. The information and the insight is in the data. Why bring the data to the data center when you can process or pre-process with AI at the edge? It's costing less, it's better for everyone, it's a better time to solution, and it is cheaper, and it's better for the Earth. And part of this will be done on your laptops. Some of you have laptops. Most of the laptops will be by 2028 AI PCs. AI PC, I'll talk about it a little bit later. I know it's not really the focus of this conference, because we all believe that AI workloads, and especially training and some good inference, runs on HPC infrastructure, but there's also a lot of AI inference that can be done on your smartphone, on your laptop, and at the edge where the data is created. And I'll talk about how we are helping secure the data on your laptop, typically, and run the AI inference on your laptop. We are bringing AI everywhere, and we announced this a year ago. That was the big message at that time, with new technologies, new tools, new solutions. That helps accelerate innovation by using commercial off-the-shelf components, as well as libraries, frameworks that have been optimized for the hardware and that are made available for free. They are upstreamed, they are open source. That helps maximize value of the hardware that you already have. Why? Because if the hardware is capable without additional acceleration, which would be discrete through an AI accelerator on a card, or a GPU, if your hardware is already capable of doing a lot of the AI, typically inference that you need, then that's better for you. You don't need to pay for the extra hardware that in some cases might be sitting idle and consuming power. If it does not consume power, then it doesn't cost electricity, which is expensive at the moment. So that's very important to look at what are your use cases, and especially inference, and how they can run either on your infra or on the edge. Because we want to deploy and run everywhere and make it easy for that to happen, while staying responsible in terms of sustainability and securing your data. So what does Intel bring? Xeon scalable processors from the second generation, I think it was, already started having some AI instructions, AI acceleration integrated in the CPU. Since servers have a lifetime of about 5 years, that's the time to replace them. Even though they already have capabilities to run some AI applications that are optimized through the libraries efficiently, it's even better if you can use the latest generation that will be even better. So that's the general purpose CPUs that we are bringing. We also bring acceleration, which is dedicated, like the Intel Gaudi solution. And all of this in an open software environment that you can use with libraries that are available, that are upstreamed into frameworks that are available as you download them. So that's very, very important. And you can choose, and you have to choose which solution you would implement depending on your use case. I will not go very deep into this, but as I said, Intel provides all of the basic ingredients, like the CPUs, Intel Core Ultra, as well as Intel Xeon, and then Gaudi, and then all of the software layer which is needed, like one API for developing applications, and OpenVINO, which is a huge and hugely capable solution for being integrated into your applications, and that will make it very easy and simple for you to take advantage of the capabilities of the hardware. As I said, the frameworks are also optimized. Software is very important, and it runs across all of the solutions, from enterprise and cloud and data center to client and to the edge. Of course, we work with all of the solution providers. We work with all of the software vendors so that as much as possible, the applications are already optimized to take advantage of the integrated acceleration that we have in our CPUs. And that goes across the board. If you look at it from the bottom, I talked about from general purpose to AI specific, so from Intel Core or Intel Xeon to Gaudi, from client to cloud, from training to inference, and from small to large language models. Let's look at training. Everybody complains at the moment that they want to do training, but they don't want to neither wait nor pay for some solutions. Gaudi is available and can help you get to that solution much faster, much cheaper. It can also do, by the way, inference. We had Gaudi 2. We introduced a couple of months ago Gaudi 3, which doubles the performance from Gaudi 2. And when you compare it with competition, typically NVIDIA H100, then you can see that training will be faster on Gaudi 3, inferencing will be faster, and the power efficiency will be better. So that's a solution that is really, really something that you could look at and should look at, because that's really interesting as a solution to your training problems, let's say. And the other important thing is that in some cases, you can take CUDA solutions and migrate them pretty easily towards Gaudi 3. I'm not saying that it will be super efficient, but at least it's a good way to start. When you want to do inference, Xeon is really the solution. It already integrates the acceleration that is needed for inference, and you can already use it because you already have those Xeon processors. The 5th generation of Intel Xeon scalable processors, codenamed Emerald Rapids, that we launched about a year ago, is capable of doing inference on some small models, 6 billion parameters, 13 billion parameters, with meeting the market requirements, which is the latency needs to be lower than 100 milliseconds. So that's great. But even though we are towards leaner, smaller, more frugal language models, we still have some issues because there are some large language models that we would like to run and do inference on. That's what the Xeon 6 with P-Core, codenamed Granite Rapids, is capable of doing, running models up to 70 billion, again, with the 100 millisecond market requirements, which means that using the libraries that are optimized for it, that are embedded in the solutions, the frameworks, or some software, then you can just run on it as is without having to develop a lot of software, and you get an extremely efficient and effective solution. But when it comes to inference, you also want to do it at the edge, typically on your laptop. And there are a few things with a laptop. Battery life, battery life, battery life. That's what everybody is after at the moment. Because usually performance is good enough, especially when you want to do your usual application like, Excel, PowerPoint. Oh, PowerPoint, yes, of course. Yeah, and that's what we do. And Outlook and stuff like this. But when you do other things like Teams, it already runs a lot of AI capabilities. Sound correction, checking your background and making sure that when you move, it goes smoothly. It uses cycles. Cycles use electricity. Electricity drains battery. So what we are seeing, in my previous laptop, I admit that it was old. I had about 1.5 hours of battery lifetime. I got a new one. I can do about 10 hours. With the next one that I'm going to get, which will be Intel Core Ultra based, especially second generation, I can run Teams, really Teams, for 20 hours. 20 hours. So that's the great thing. Why? Because Teams has been optimized to use the NPU. So when it does all of the AI stuff, it runs it on the NPU, which is super low power. The CPU will work on some other stuff. The GPU will work on the display. And there are those three parts in the Intel Core Ultra processor. That's how it works. We announced it in September, the second generation of Intel Core Ultra. What is important is that it is Copilot Plus, because it has an NPU with over 40 TOPS. But is 40 TOPS an important metric? Could be for marketing, but for us who want to use it, we need to make sure that the applications will take advantage of the TOPS in the NPU. Guess what? Not every application is optimized for that. There's still some AI that runs on the GPU part. There's still some AI that runs on the CPU part. And with that solution here, if the application is optimized for NPU, then it will use the NPU. Otherwise, it will run extremely efficiently with up to 100 TOPS on the whole CPU using the right part that is needed, the right engine, GPU, CPU, or NPU. I had so many discussions with users or, let's say, execs who wanted a laptop that would last more than a day because they didn't want to be on the train carrying their power supply. And then they said, hey, you know what? ARM is my solution. OK, that might be, because ARM is known for delivering CPUs that have a good power efficiency in terms of battery life. Great. But remember that it is not the battery life in some synthetic applications and benchmarks that matters. It is what you run on it. So what we decided to do, and you can see here, we did it with the Core Ultra 9, as well as the 7, which is the baseline, against a Qualcomm. And that was a little bit earlier this year. So we took some applications, and we ran them. Guess what? Did not run is something that we have seen too many times. Why? Because it's not only about the engine, it's not about the CPU, it's about also the ecosystem software enabling. Intel has thousands and thousands of engineers developing software. We have been working with the independent software vendors for decades to run and optimize their applications on our hardware. And that pays off. That's running. So don't think about, do I need a Ferrari or a Renault or whatever? What do I need it for? And which one is the right one for me? A cheap one might be the right solution. A fast one might be the right solution, but it really depends. If you take a Renault, then you will have space to put some stuff in the trunk. If you have a Ferrari, and sorry, Walter, I know you're Italian and you might not like that, but you won't have space to put stuff in the trunk. What do you want to do with your solution? Choose the right hardware for your use cases. And when you have to develop new environment, new applications, you want them to be running everywhere. You don't want to develop for one target. So we decided to help create another environment that is open source. It's the open platform for enterprise AI, which aims at developing models, frameworks, compilers, and tools that are making the building blocks that will be usable everywhere, and on solutions that will be hardened and trusted. This is very important. Now, how does this translate into two examples? First one is keep your data secure. When ChatGPT was starting to being used, we all heard about some employees of very large companies that had asked for help from ChatGPT. They put some software code for checking it, and guess what? In that code, there was some IP. Once you put data on ChatGPT or wherever, it goes public. It is used for being trained. It is used for others to use. Keep your data secure inside the enterprise, because the data is, and the IP is the crown jewel of the enterprise. That's how we worked with Boston Computing Group and created a solution which is generative AI secured inside the fence of the enterprise. Gaudi, you have heard about it. Everybody talks about it. It's a great alternative to some other solutions. And we have been, here it's a POC, we have been working with Sweden municipalities, and the challenge is they want their employees to be dedicated to helping their the people living in the municipalities. So in order to do that, they found out that the employees are spending a lot of time searching for answers to questions. And they wanted to work with us on solutions that would be helping people dedicate their time to the people, the employees dedicating the time to the people they have to serve. We did a POC with 6 and going to 15 municipalities, testing it, RAG solutions, working very well, and running on Gaudi. Listen to this.
Large language models are extremely useful when it comes to things tasks. And the public sector in Sweden is probably one of the greatest beneficiaries in this stage of large language models and language technology.
If we take an example of the February fair, we have assistant nurses that are spending a lot of time on text-related tasks. They are looking for information
Public sector. Which government wouldn't like to have something that is much more efficient? France is not doing very well at the moment in terms of economy, and I, as a consumer of the public sector, I'm always unhappy that I cannot find an easy answer to all of my questions. I'm wasting my time, I'm wasting the time of the public sector employees. If we had a solution like this, which is working in Sweden in 6 municipalities, we are working on getting it to 15 and then to a lot more, then it can be replicated in some other countries, in some other public sector environments. This would be great, and it's really close to my heart, because if you have a nurse who is searching for information instead of taking care of the patient, I'm sorry, but my parents are aging, and I would like the nurse to be taking care of my parents rather than do something else. So this is very, very close to my heart, and something that I will be keeping on pushing a lot, and I'm sure that it can work in plenty of countries. Last slide. What we aim at doing is solving the AI challenges, reduce cost and complexity, increase the productivity, eliminate the guesswork, ensure choice and flexibility, not having your hands tied with a certain provider or solution, and keep your data secure and be responsible in terms of sustainability. So one last thing that I will say is about keeping the data secure. I was in an event where we were showing how you can take a picture of yourself and morph it into something like a superhero. Kids do that. How do they do it? They upload their picture to the cloud, to the internet, to wherever, and then it goes public. With an Intel Core Ultra solution, the OpenVINO application runs on the laptop, takes the picture from the laptop, processes it, keeps the data on the laptop, and I talked with many parents who told me, wow, okay, so now I understand what secure means. The picture of my children will not be accessible to people who might have bad ideas. So, just something like that, wow, that makes a big difference. All this runs on Intel with Intel Portfolio. The future is bright. Thank you very much.
Another round of applause for Dr. Felipe. Thank you so much for the insightful presentation. I think it got to show us, because there's always a lot of debates in terms of what are some of the practical and tangible uses that AI can benefit, not just businesses, but society as well as government. Thank you so much for those insights. And maybe, do we have one question before we let Dr. Felipe go? But there will be other opportunities to interact with him, because we have up until the end of the day. Thank you. Any pending questions?
Yeah, and I will stay until end of the dinner tonight. So if you want to have discussions about everything on AI and the rest with me, don't hesitate. Thank you.
Thank you, Dr. Philip. I don't see any hands. This is something to say. Thank you so much
Thank
for
you.
taking time to join us. And we are hoping that this won't be the last time that we see you in South Africa.
No, that won't be.
Thank
It
you.
cannot be. Thank you so much.
Thank you so
Thank you.
much.